Okay, so on this question, it says you want to obtain a sample to estimate a population proportion. At this point in time, you have no reasonable preliminary estimation for the population proportion. You would like to be 95% confident that your estimate is within 1% of the true population proportion. How large of a sample size is required? Okay, so what is going on here? So the key part to focus on is that last sentence. How large, highlight that, how large of a sample size is required? So in other words, how many people do we need to include in our study to get the kind of accuracy that we need to get? So, right, we want to figure something out. We're trying to estimate, like you might be saying, I want to figure out, what percentage of the people are going to vote for this, on election day are going to vote for this certain ballot measure, this candidate or whatever. Or, you're trying to figure out what, this, we have this new medical treatment for skin cancer, and we think it's better than the old one. We want to estimate what percentage of the people are going to be cured by it in the long run. How many do we need to try it out on? 50 patients, 100 patients, 1,000 patients? How many people do we need to try this on if we want to be what? 95% sure, confident that our estimate is within 1% of the true population proportion. In other words, if you had some new medical procedure and you wanted to know within 1%, you see that key word right there, within 1%, what the true population proportion is going to be. In other words, well, 10 years from now, the truth will be known, right? After thousands and thousands and thousands of patients have tried the new skin cancer treatment, we'll know, hey, 91% of the people who do the new skin cancer treatment are cured by it, for example. I don't know. I'm just guessing. We'll know it in 10 years. Well, we want to know now. We want to estimate. We want to become 95% confident that the estimate we can come up with is within 1% of what the true number will be known 10 years from now, right? Because we want to figure out should we be using it or not. And so we want to get close to the real thing. So how many patients do we need to survey if we want to try to get that accurate? How large of a sample is required? Well, for that, let me go to the notes with you real quick. So here's that's not the notes. Here's the Unit 3 chapter notes. Confidence intervals there to sample size. Number 3, sample size, finding in. So first off, identify whether it is a percentage or in the mean average, right? So part A is percentage, part B is mean average. Back to the question, this is a proportion. See the word right there? Proportion, percentage, same thing. So then we go, okay, so it's up here. It's a percentage question. So where do we go? Online calculator, sample size for a proportion. So we go, okay, let's go to so here's the online calculator. You know how to get to that. Just click the calculator on the home page. So we get to the online calculator, come down here. So notice how we have sample size for mean. That's not the one we want. Sample size for proportion. There we go. That's the one we want. So number 13. So click on that one, sample size for proportion. And I just did. There we go. It opens up. Okay. So notice there's these two radio buttons. No estimate for P, have an estimate for P. Back to the question. See how it says, right? It says, at this point in time, you have no reasonable preliminary estimation for the population proportion. You don't have an estimate for the proportion. You have no idea what the proportion might be. You have no estimate for the proportion. Sometimes we do, sometimes we don't. Sometimes you know ahead of time, I know it's going to be around 85% or whatever. It might be a little higher, a little lower, but it's about 85. We don't know. We have no estimate. So we say, okay, I'm going to click on well, it's already selected, the no estimate for P. Okay, what do you put for E? It says fill in the air-bound E and confidence interval written as a decimal. So both these have to be decimals. Go back to the air. Here we go. See how it says, it says, and let me show you the notes. The air, E equals the air within amount. So when it says within, that's the air. You want to be within that amount, that amount of air of the real thing. You're trying to predict in the future what percentage of people will be cured by this new treatment. So you're going to make an A, you want to be within an error of 1%, they said. Back to the question, it says we want to be within 1%. That's the error. That's the E. So back to the calculator, the E. But can I just put in one then? 1%? No, it's got to be a decimal, remember? All percentages, when we put them into the calculator, we always change them to a decimal. So that'd be 0.01. That's our 1%. That's the error. That's the within, right? You want to estimate within 1% of the true thing. 1% error. Okay, and 95% confidence interval, again, that's a percentage. So what do we always do with the percentage? Make it a decimal. So both those, we make them decimals, back two places, 0.95, 0.01, calculate in. 9604. Let me copy and paste that. Control copy. 96. That means 9,604 patients must be. You must give the new medical treatment to 9,604 patients if you want to predict within 1%. If you want to be 95% sure that you've got the real answer within 1% of what will be found out in the future. Let's see if that answer is right. Paste it in there. 9604. It is correct. And so there we go.